Hello, this is Keith Tipman with Study Time Tutoring, and today we're going to go over a few acid-base practice problems. Okay, for this first one here, we're looking for the hydrogen ion concentration of a 0.01 molar solution of acetic acid. It gives us the Ka here for acetic acid, which is 1.8 times 10 to the negative 5. So obviously to get this problem correct, you're going to need to understand what Ka is. And so as a quick review, Ka is going to be the concentration of the products multiplied by each other and then divided by the reactants. If you need a quick review on what Ka is, I recommend checking out our video on Ka and pKa. Okay, so for the first step, what we're going to do here is we're going to plug in the values given to us in the question. And so the values for X are going to be whatever the concentration of hydrogen ions are here. We don't know that value, so we're representing it with a variable. Now this next step here is where I lose quite a few students. So let's take a look at this next step here, and you'll notice essentially what we do is we eliminate the value for X on the reactant side. The reason why we do that is the value for X is very small. So essentially what we're going to do is ignore it. Alternatively, we would have a quadratic to solve for. And so by eliminating a value for X, it makes it a lot easier on us. And the reason why we can do that is because acetic acid is a very weak acid. So it's going to donate very few protons to solution. It's not going to disassociate that readily. And so once we do that, all we need to do is solve for X. So you see the first step here is multiplying by the denominator, 0.01. That gives that value out of the denominator. And then what we're going to do is square root both sides to get X by itself. And eventually that'll give us the value for X. So our value for X is equal to our hydrogen ion concentration. So therefore, our hydrogen ion concentration is going to be 4.24 times 10 to the negative fourth. Now again, if you're having any issues with this question, if you don't understand why we eliminated the X, if you don't understand ice tables, for example, you may want to check out a few other videos on this subject. Okay, so for this one, it's pretty much an extension off the last problem. So we have the same solution. We have 0.01 molar solution of acetic acid, and the Ka, again, for acetic acid is 1.8 times 10 to the negative 5, negative fifth. So we know here that the pH is essentially the negative logarithm of whatever the hydrogen ion concentration is. And from the last problem, we got the hydrogen ion concentration at 4.24 times 10 to the negative fourth. So all I'm going to do is just plug that number into a calculator, take the negative log of that number, and it's going to give me 3.37. So that means the pH here is simply 3.37. Okay, and so for this last one here, we're starting with the pH, and so we need to work backward and find out what the hydronium ion concentration, or H plus concentration, is for this soda. So to work backwards and find the hydrogen ion concentration, all you're going to do is take 10 to the negative value for the pH, and that will give us the hydrogen ion concentration from a pH value. So when we plug in 3.4 into this equation right here, we will get a hydrogen ion concentration of 4.0 times 10 to the negative fourth moles per liter of hydrogen for this soft drink. Now, again, if you struggled with any of today's problems, you may want to check out our video on pH or pKa. That'll help you understand a little bit of what's going on here. Additionally, if you kind of look back to some other content, you may want to consider reviewing KSP. If you review KSP, that's really going to help with understanding what's going on with solubility. Additionally, it may help you out with ice tables. That's a common stumbling block for quite a few students. So if you feel kind of unprepared for this acid-base unit, again, I'd recommend checking out some videos on KSP. Well, thanks for watching today's video. Please consider liking and subscribing, and catch you all in the next one. Peace.